Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about static electricity. So what actually is it? Well, we need to go back a few steps and look at what the words insulators and conductors mean. So an insulator, such as plastic or glass, these are materials that prevent electrons from flowing through them, and essentially they are left static. They just stay as they are. They can be transferred, and we'll explain what I mean by that in a few moments' time. But that's where the word static comes from. So those electrons just remain as they are. They remain in stasis. They are not moving in the way they are in conductors. So, for example, in metals, you will see that those electrons are able to move through the metal quite easily. And that's why electricity flows through them. That's why we say metals are good conductors of electricity, but also good conductors of heat as well, because they're able to transfer through that material. So let's have an exploration into static electricity examples. So you may have actually seen static electricity in real life. If you've ever got a balloon and rubbed it against your head, you'll see that your hair will actually stand on end. And this is because the static that builds up on that insulated material, that rubber, actually the electrons actually get transferred, and it causes repulsion forces between each of your hair strands, and that's why they start to separate in the way that they do. So anytime you get an insulating material and you add a frictional force, you rub them together, you're actually transferring some energy to those electrons, and that helps them escape the shells, the electron shells that they're in, and essentially those electrons are moved or rubbed off onto the other material. And that way you actually build up charge. So if we give you the example, we have a plastic rod, polyethylene, for example, and a cloth. These are both insulating materials. And this is an example that often comes up at GCSE, which is why I'm sharing this with you now. So if you have a look at those two objects, you've got the polyethylene rod, the plastic rod, and the fabric cloth as well. And if we were to rub those objects together and apply a frictional force, the electrons that are on the polyethylene rod will actually build up and get transferred over onto the cloth, causing the cloth to be negatively charged overall and giving the rod a bit of a positive overall charge as well. This will actually cause the transfer of charge, and therefore you're able to do something quite cool. So I've actually done this before, where you get your polyethylene rod after you've applied a frictional force to it with a cloth, and you can actually start to pick up small pieces of paper. And this is because there is an attractive force between the pieces of paper and the polyethylene rod now, because you've transferred those electrons. You can also do this by applying a frictional force to a balloon and rub this with a cloth, and you can actually place it onto a wall and it will essentially attach itself to it. And this is because of the attractive forces between the positive and negatively charged objects. And like I said with the hair example, when you apply a balloon to your hair stands on end because each of those hair strands are applying a repulsion force. They are repelling one another because of the similar charges that they have. I hope you found that video helpful. I know it was a quick one, but I did want to share this last bit of the electricity topic with you. I have also linked all the videos that we did in electricity in the playlist here, and another video if you were interested in maybe biology or chemistry. And if you want any more support with GCSE science, I have my social medias on the other side for you to check and see if that is something you're interested in. So thank you so much for watching. I've been the GCSE science teacher and you have been curious. I'm really, really happy to have you here. So if you would like to subscribe, feel free to, and I'll catch you in the next one. Take care. Bye.